Hello learners, welcome to this lesson. My name is Teacher Agnes. I'll be taking you through mathematics. Our topic today is quadratic expressions and equations 2 because we already did the first part of this topic in Form 2. Our subtopic today is factorization of quadratic expressions. So to get started, I would like us to remind ourselves of the difference between an expression and an equation. Now, the most obvious difference is that for an equation, there is always an equal sign, but for an expression, there is no equal sign. What that means is that you cannot solve an expression, but you can solve an equation. So quadratic expressions, how do they look like? So quadratic expressions are always written in the form of ax squared plus bx plus c. So note that there is no equal sign. The moment you introduce an equal sign, you will be trying to create an equation. So it is important to note that a, b, and c are integers, okay? That means that they can be positive or negative whole numbers, and a cannot be equal to 0, all right? A cannot be equal to 0 because if a is equal to 0, then it will be 0 times x squared, which makes the entire term to be 0. And if that is the case, then that expression cannot be referred to as a quadratic expression, because the main reason why this is a quadratic expression is because the x here is squared. So if you lose x squared from this expression, then it cannot be defined as a quadratic expression. So now, since we cannot solve expressions, what do? We factorize them. That is why our subtopic today is factorization of quadratic expressions. So you're going to learn how to factorize them using examples. So examples on how to factorize. We're going to do one together. So we're going to factorize x squared plus 6x plus 9. Now, for us to be able to factorize, we must be able to have 4 terms because we need an even number of terms. In this case, we have 3. X squared plus 6x plus 9. 1, 2, 3. So we need 4. So for us to create 4 terms, we will have to break 6x into 2. So how you do that is by asking yourself, which 2 numbers can you multiply to give you a product of 9, so the value of c, and the same numbers add to give you a sum of 6. So the sum is derived from this value and the product is derived from this value. Alright? Now, the best way to come up with these numbers is to think about which numbers can you multiply to give you 9. We have 1 times 9, which is equal to 9. But if you add 1 and 9, you get 10. That doesn't give you 6. So you can take 1 and 9 to be the numbers that you need for this particular question. So let's test another set of numbers that when multiplied can give you 9. So the other numbers are 3 and 3. So 3 times 3 is 9. 3 plus 3 is 6. So that means that the numbers that you're going to use to factorize this expression are, 2 3s, a 3 and another 3. So how do we use them? Like I said, we are going to break 6x into 2. So this will become x squared. Now since 3x plus 3x gives you 6x, we're going to have plus 3x plus 3x plus 9. So you notice that 6x is the same as 3x plus 3x. So at this point, we are going to factor out what is common between any 2 terms. So starting with the first 2 terms, there is no number that is common. but x as a letter is common. So if you factor out x, so x squared divided by x, that gives you x, plus 3x divided by x, that gives you 3, plus, so between these two terms, so there is only one letter, there is no letter here, so we can't say that x is common because it doesn't appear in both numbers. But when you look at the numbers, we have 3 and 9. Now 3 is common because 9 is divisible by 3. So we factor out 3. 3x divided by 3 is x, plus 9 divided by 3 is 3. So now you have factored out the values that are common. And you notice that the ones inside the brackets are the same. So you have x plus 3, then x plus 3. So that means that the factors are common. So you pick one, which is x plus 3. And then you multiply this factor by the two values outside the brackets that are multiplying, the factor inside the bracket. So you have x plus 3. So x plus 3. So this is the final answer as a factorization of the expression x squared plus 6x plus 9. We are now going to look at another example. Now we are going to look at this example where we are going to factorize x squared minus 5x plus 6. So the way to do it is the same. So we are going to identify two numbers such that if we multiply them, the product will be equal to 6. And the sum of the two numbers will be equal to -5. Alright? So two numbers such that if you multiply, you get 6. And if you add them, you get -5. Then we have to consider that the product 6 is positive. This means that the two numbers, or both of the numbers that we choose, must be negative. So think about two numbers, two negative numbers, such that if you multiply, they give you 6. So we have the option of -1 and -6. So if you multiply the two, you get 6. However, if you add them, -1 plus -6, you get -7. But we want to get -5. So we cannot use these two numbers. So think again about two negative numbers such that if you multiply, you get 6. So we have -2 and then -3. If you multiply them, you get 6. And if you add them, -2 plus -3, you get -5. So these two are the numbers that we are going to use to break -5x into two terms. So rewriting the expression, we have x squared, then -5x can be written as -2x minus 3x, because these two, -2x minus 3x, gives you -5x. Plus 6. So now we have 4 terms, which is why we were breaking down -5, and you can factorize the first 2 terms and the other 2 terms. So looking at these 2 terms, x is common. So you factor out x, and then you have x squared divided by x is x, minus 2x divided by x is 2. Then looking at -3x and 6, -3 is common, alright? So -3 is common. So -3x divide by -3, you get x. Then 6 divide by -3, you get -2. So please be careful here so that you don't just do 6 divided by 3 to give you 2. Do not forget the negative, because 6 divided by -3 is -2. Now looking at this, we can see that the values inside the brackets are the same. So that is a common factor, which is x minus 2. Now it is being multiplied by x in the first part and by negative 3 in the second part. So this is a full factorization of the expression x squared minus 5x plus 6. Now we're going to look at an example that is a little bit different from the first two. In this example, there will be another value next to the x squared. So let's look at it. Now in this example, you notice that we have 9 as a coefficient of x squared. The others, the value was just 1, which is why we did not consider it. So in this case, we have to consider that 9 when it comes to getting the product. So we need two numbers such that when you multiply them, the product, we are not now only going to consider 1. We're going to multiply 9 times 1. 9 times 1 is 9. So we are looking for numbers such that if you multiply them, you get 9. And the sum will still be negative 6. So from here, all right? So the 9, we use it to get the product. So 9 times 1. So you multiply the first value and the last value, which gives you 9. So considering that the sum is negative, then the two numbers must also be an aspect of being negative. But since the product is positive, then both numbers must be negative. So which two negative numbers can you multiply to give you 9? So the two numbers are negative 3 and negative 3. So we are going to use them to break negative 6x into 2. So now we have 9x squared, and then negative 6x is written as negative 3x minus 3x, then plus 1. So now we are going to factorize, starting with the first two terms, 9x squared minus 3x. So now here, we have both numbers and letters being common, because when you look at 9 and 3, they are both divisible by 3. So we factor out 3. Then we have x squared and x. So x is common. So 9 divided by 3 gives you 3. X squared divided by x gives you x. Minus 3 divided by 3 is 1. X divided by x is 1. So 3x divided by 3x is 1. Then now when you look at the other values, we have negative 3 and 1. So the factor that is common there is 1. Alright? So minus 1 is common. Then now we have minus 3x, minus 3 divided by negative 1, that is 3. X just remains because there's nothing to divide it by. There's no factor, there's no letter that has been factored out. And then we have 1 divided by negative 1, which is negative 1. Okay? So when you look at the values inside the brackets, you notice that they are the same. So you pick one factor, so you have 3x minus 1. Now both of them are being multiplied by 3x minus 1. So that is a full factorization of the expression 9x squared minus 6x plus 1. Now to emphasize on this concept of having a value before x squared, we're going to do one more example. Example 4, we're going to factorize the expression 4x squared plus 4x minus 3. So again, we start by getting the product. So since this is not 1, we are going to multiply 4 by negative 3. So 4 times negative 3 is negative 12. And then the sum will be, the middle value, which is 4. So now we are looking for two numbers such that if we multiply them, we get negative 12. And if we add, we get 4. Now you have to note that the product is negative. That means one of the numbers will be negative. Now since the sum is positive, then it means it's the smaller number which is negative. Alright? So two numbers, if you multiply, you get negative 12. So I can think of, negative 3 and 4. So two numbers that you multiply to give you negative 12, I can think of negative 3 and 4. But if you add them, will they give you 4? So negative 3 plus 4 is 1. So we can't use them. Let's try another set of numbers. So we have negative 6 and then 2. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. We need positive 4. So we can't use this. That is why I stated that the smaller number is the one that needs to be negative so that the sum can be positive. So let's look at negative 2 and 6. Negative 2 times 6 is negative 12, and negative 2 plus 6 is 4. So these are the numbers that we are going to use. So now we use them to break 4x. So we have 4x squared. So instead of writing 4x, we have minus 2x plus 6x, and then minus 3. So now we can factor out what is common. So between these two, we have 4 and then 2. So 2 is common. Between x squared and x is common. So if you divide, 4 divided by 2 is 2. X squared divided by x is x. Minus 2x divided by 2x is 1. Then looking at the other two values, 3 is common. So we have plus 3. 6x divided by 3 is 2x. Then negative 3 divided by 3 is negative 1. So now we have that, and if you look at the values inside the brackets, you notice that they are the same. So now you pick one of them, 2x minus 1, and then you multiply by the values outside the brackets. So we have 2x plus 3. And that is the full factorization of 4x squared plus 4x minus 3. So now we are going to do some sort of analysis of the 4 expressions that we have factorized, because I want us to be able to identify expressions that are known as perfect square expressions. Now, these 4 quadratic expressions are the ones that we have factorized in the examples. If you look at the solutions, you will notice something unique with the first two. So the first two, after factorizing, we obtained x plus 3 times x plus 3. The next one is 3x minus 1 times 3x minus 1, which is different from the other two, x minus 2, x minus 3. So for the first two, the factors are the same. They are equal. X plus 3, x plus 3. So this is like multiplying this factor by itself. So we can write it as x plus 3 squared. Then in the second one, we have 3x minus 1 times 3x minus 1. So you are multiplying it by itself. So you can have it as 3x minus 1 squared. Now we can't do the same for the other two because the factors are different. 2x plus 3, 2x minus 1. So these two are given a name, and they are known as perfect square expressions. Okay, perfect square expressions. So the others are just expressions, but the two can be categorized as perfect square expressions. Now, to practice what we have learned today, you will attempt these 4 questions, factorize the following, and actually identify which of these expressions are perfect square expressions. So we have x squared minus 6x plus 8, 2x squared minus x minus 6, 16x squared minus 8x plus 1, and finally x squared plus 12x plus 36. So I hope that you have learned how to factorize quadratic expressions in this topic. See you in the next lesson.